Hi, I'm Jake from Jakeology. Have you ever looked at a smokestack at a power plant and wondered what was coming out of it? Do you ever get a warm and fuzzy feeling when baby ducks are rescued from oil spills? If you answered yes to any of these questions, then stay tuned while we look into the environmental impacts of power plants. Let's get nerdy, people! What is environmental science? Environmental science is the study of natural environment and the interactions between its physical, chemical, and biological components. Environmental scientists investigate and try to solve problems like climate change, pollution, and biodiversity loss, and natural resource management. Environmental science is a broad field that includes ecology, geology, chemistry, biology, physics, and even mathematics. My mom is an environmental scientist at one of Tennessee Valley Authority's natural gas power plants. Let me give you a little background about what that is. Let's go back to the 1930s. The stock market just crashed and sent us into the Great Depression. The Tennessee Valley Authority Act was signed in 1933 by President Franklin D. Roosevelt to do four things: improve navigation of the Tennessee River, provide flood control, develop industry, and operate the hydroelectric Wilson Dam. During the Great Depression, people in rural towns in the South were mostly poor. There were very few jobs available, and most people living outside larger cities didn't have electricity. Bringing electricity to these areas sparked economic and industrial growth they'd never seen before. Today, TVA has 3 nuclear power plants, 4 coal-fired plants, 29 hydroelectric sites, 17 gas plants, and 9 solar sites. So, how does natural gas units work? It's all about energy conversion. Power plants convert heat energy into mechanical energy and then into electrical energy. Here's a simplified diagram with all the outer parts removed so you can see how the guts of it work. Air is needed for combustion. It enters here, the air compressor, and then continues into the combustor, where natural gas or fuel gas is injected and burned with an igniter, which is like a big lighter. The heated gases then pass into the gas turbine, which is full of blades, like a huge pinwheel. The air strikes the blades, causing them to rotate, and ta-da! We've just converted heat energy into mechanical energy. As the blades rotate, they also cause the shaft, called a rotor, to rotate. What is this rotating shaft also connected to? The generator. We'll get to that in a second. What is this line for? This one right here. It is the exhaust. The leftover hot air that blew through the turbine. Where is it going? It's making its way to something called the Heat Recovery Steam Generator, or HRSG. A HRSG tries to increase efficiency. We have all of this hot air. Why let it go to waste? And now we cue the water. Water passes through tubes in the HRSG. What happens when the water is heated? That's right, it's converted into steam. The steam then goes to the steam turbine, which is also attached to those rotating parts. The blades spin to help turn the rotor. It's like the difference between one person pushing a merry-go-round versus 2. The more pushers there are, the more easily it spins. As the steam cools off, it condenses back into water and returns to the water reservoir, where it gets reused over and over and over again. So what's the generator that these turbines are helping to turn? Generators operate based on the principle of electromagnetic induction, which pretty much says that if you move a magnet through a wire, then an electric current is produced through the wire. Here's a diagram of the generator. If you'll notice, we have the Antriebachse. Oh wait, you don't speak German? Hold on, there you go. That's the rotor that makes everything spin. Notice it's connected to the magnetic parts. those magnetic parts rotate inside a bunch of wires, which, thanks to the principle of electromagnetic induction, produces an electric current. Ta-da! We have now converted mechanical energy into electric energy, which is transported into your house through miles of power lines.
So why do we need environmental scientists? The short answer is to monitor air, water, and waste.
As much as we love our televisions, laptops, and phones, the production of this much power has its downfalls. Anytime fossil fuels like coal and natural gas are burned, there will be pollutants emitted into the environment. And why use natural gas? Because it burns cleaner and releases fewer pollutants than coal and produces more electricity than renewable sources like hydro and solar. Right now, technology doesn't exist to provide enough renewable power to supply all of our needs, but trust me, scientists and engineers are working on it. In the meantime, we have to mostly rely on fossil fuels and nuclear power.
What are the pollutants that are produced? Excellent question, viewers. A lot of it depends on what type of fuel you burn, whether coal or natural gas, or heck, you can even use, nuclear energy. But that's a story for another day.
Let's take a look at what happens during the combustion of natural gas. CH4, or natural gas, plus oxygen, because oxygen is required to burn, plus nitrogen, and the atmosphere yields carbon dioxide, water vapor, and nitrogen. That's what should happen in a perfect world under perfect conditions. But things aren't always perfect. Humans aren't perfect, and equipment occasionally malfunctions. One problem happens when there is too much heat. This nitrogen that normally wouldn't participate in the reaction at all can become reactive when it is heated too much. Then it can form nitrogen oxides, or what we call NOx. If you've never heard of NOx, then these gases contribute to the forming of smog and acid rain. What's acid rain, and why should we care? Normal rain has a pH of about 5.6. Fun fact, rain is slightly acidic because of its interaction with carbon dioxide, which forms carbonic acid. Acid rain has a pH between 4.2 and 4.4. Nitrogen dioxide from combustion combined with oxygen and water vapor to produce nitric acid. When acid rain falls into lakes and streams, it can cause them to be acidic, which is detrimental to freshwater ecosystems. How do power plants control NOx? There are probes inserted into the exhaust of the plant. These probes measure the amount of NOx, and environmental scientists collect this data and submit it to the Tennessee Department of Environment and Conservation, or TDEC. They have to show that they are maintaining and monitoring equipment. There are limits to the amount of NOx that can be released into the atmosphere.
With NOx in check, what else do we have to watch out for?
If you'll notice, the carbon dioxide is also produced during combustion. We exhale carbon dioxide, so why should we care about it? It's harmless, right? Right? Wrong. Carbon dioxide is a greenhouse gas. When sunlight reaches the earth, some energy is absorbed and re-irradiated back into the atmosphere as infrared waves, or heat. These rays should escape back into space, but something stops them. Carbon dioxide absorbs waves with wavelengths between 2,000 and 15,000 nanometers. Infrared waves fall in this range. About half of the infrared waves manage to escape, but carbon dioxide molecules absorb the other half and re-irradiate them back to the Earth's surface. Temperature depends on the balance between how much energy comes in and how much energy goes out. Warmer air can also hold more water. Seeing as warm, wet air is the driving force behind tropical storms, the greenhouse effect contributes to hurricanes and flooding. Fun fact, an example of the greenhouse effect is not only seen on Earth, but also on Venus, where the atmosphere is 95% carbon dioxide. This explains why Venus is the hottest planet in the solar system, even though it is not the closest planet to the sun. Probes also monitor how much carbon dioxide as well as several other gases is being added to the atmosphere as a result of combustion.
That's enough about air. Time to learn about some water.
Some power plants use river water to cool the equipment. After passing through the power plant, this water is returned to the river. To make sure there's no contamination along the way, the water must be tested. We can't disrupt the water quality and harm aquatic life. Scientists or technicians will collect a sample of the water and use a pH meter to find the pH. And they'll use a certified thermometer to find the temperature of the water entering the river. Again, these numbers are reported to TDEC by the environmental scientists. Samples are also collected to determine if any metals have been picked up in the water. Here are some of the metals that most plants are looking for. These metals can be consumed by humans by drinking or by passing through the food chain. Heavy metals can cause several unwanted effects like kidney damage, liver failure, gastric problems, mental retardation, and reproductive effects in humans. Again, there are some limits that must be met. Water samples are put in ice in a cooler. Then they're sent to a laboratory for analysis and reported to TDEC. Other things that are checked are oil and grease and suspended solids. TVA can't dump any of these things into the river. Samples are collected and sent to a lab and, like everything else, reported to TDEC. Sometimes equipment malfunctions. Sometimes vehicles or boats have oil leaks.
Environmentalists inspect the site daily. If any spills happen, it's the job of the environmental scientists to make the notifications necessary for cleanup. They also notify TDEC, as well as the EPA, or Environmental Protection Agency. Last but not least, power plants have waste. Waste is produced during the maintenance of equipment, cleanup, upgrades, and several other processes.
We're not talking about normal trash. We're talking about things like paint chips that have been blasted off before repainting, oil from a truck's oil change, or any number of products used on vehicles or equipment on the site. We can't just throw them in the garbage. We have to make sure the waste isn't hazardous. Samples are collected from the waste and sent to a lab and analyzed for metals or other hazardous components. Once the analysis is received, the waste is disposed of appropriately so nothing harmful makes its way into the soil or water. When possible, some things are recycled. Some things we recycle are fluorescent bulbs, batteries, aerosol cans, scrap metal, and old electronics.
These are just a few things my mom does on a daily basis.
Every now and then, she is called to chase off stray dogs or relocate a bothersome skunk. It's her job to make sure migratory and nesting birds are protected. She even has the exciting job of watching dust to make sure it doesn't blow off the property and into the neighbor's land. She walks the grounds and makes sure no soil erodes in the streams. She protects wetlands and plants in them. She makes sure no one drives into archaeological areas that may contain Native American artifacts. In a nutshell, she does a lot of weird things.
How does someone become an environmental scientist?
A college degree is required. This can be in environmental science, ecology, biology, chemistry, or geology. It is possible to have other majors. Within TVA, you can start as an environmental technician. Technicians are the ones who collect weekly samples and perform a variety of inspections. After some on-the-job training, a technician can apply to become a scientist.
If maybe an environmental scientist's job isn't your cup of tea, TVA has a variety of specialists.
You might be interested in becoming one of their biologists, archaeologists, water specialists, waste specialists, or air specialists. They even have environmental lawyers. If mechanical or electrical parts interest you the most, you can become an engineer or an electrician.
But if you don't mind walking through mud, collecting samples on rainy days, analyzing and reporting data, collaborating with specialists, and occasionally rescuing injured owls, then maybe environmental scientists is for you. Stay nerdy. Roll the outro. Hope you have a good day, guys.